Welcome to my 6th video for our series about making an action RPG in Unity. In this video, we're going to get the enemy to move towards the player just kind of blindly. Just going to go straight for the center of the player, and we'll chase the player from any distance. And so this is going to be a coding heavy one, since we're not going to be adding any graphics or assets. And so I guess let's get that to work. Because right now the enemy doesn't move. We can push it around, we can hit it, and that's kind of about all it does. So let's maybe add another blob just so we can see a couple of these ones moving. We'll put one here, and we'll put another one here, so that they'll come chase me down the bridge. And so we're going to go to the enemy code to do most of this. So I do want to set up a few more variables pertaining to movement. I know we have a lot already, but we're going to need a few more. So first up is we're going to need another protected transform, and this is going to be target. So the target is the thing the enemy is going to be chasing. And in this case, it's going to be the player, but in theory, it could really be any other game object, really. Then we need to have a location they want to go to. So this will be a vector 2 called target location. And that's going to be where the enemy wants to go, which is usually the location of the target, but not always. Maybe it's going to be a waypoint. Maybe it's going to be its home position. So it's different than the target. The target could be empty, but it will always have a target location of where it wants to stand. And this one is another one. We'll call this target direction. We'll call it target direction vector. And that's just the vector to the target, which is basically just the target's position minus the current position. But it's still useful to keep that as something that we're going to calculate kind of frequently, actually. So then we're going to create a target location distance, and that's going to just be how far is the location we want to go, so that we would know when to stop moving, for instance. Move modifier. This is going to be usually 1, but maybe if the enemy is attacking, maybe the move modifier could be set to something different so it's not moving full speed while it's attacking. Or for some enemies it might be 0, so that they would stop when they stop to attack the player. So we've added these variables, total of 6 new ones under the movement section. And let's then head down to actually start setting this up. I guess to be able to test it, we are going to make use of the on-draw gizmos. Since we've already got the little checkbox, if we recall right here, the protected draw gizmos, let's add that so we can start watching the enemy, so we can make sure that it is correctly picking its location it wants to go to. So we're using the private void on-draw gizmos. If debug draw gizmos, and then let's do the draw a line to the target location, and we'll make this cyan. Actually, cyan's, I use that for at the bottom of the sprite. Let's just make this blue then. So gizmos dot draw line from its current position dot transform dot position to the target location. So it'll draw that line. And then I guess since we're dealing with this, let's also do the sprite renderer one. And this is going to calculate the bottom of the sprite. We do actually have to bind sprite renderer to the component because this can actually run during the editor, and in that case it may not be bound because start may not have been run yet. So we do have to we do have to bind sprite renderer ahead of time. And so let's do our calculations here of the lower two parts. The y value is pretty straightforward. It's just going to be sprite renderer dot bounds dot min dot y plus that offset that we had, and then we'll just do the bottom left is going to be the sprite renderer dot bounds dot min x, which would be the left side of the sprite, comma y value. And then we're going to do the same thing for bottom right, except for we're going to use the max for the x. And then we'll just draw this on. This one is the one that we're going to do in cyan. And so that will draw the line to the bottom of the sprite of the monster. We can save this real quick before we get into actually making the move method. And we can actually see the enemy if we turn that on. We'll turn on the gizmos for all these guys. So let's get to orange blob here. Gonna turn on draw gizmos. And you can see that it's actually setting it to its desired destination to 0, 0. And then we'll turn on the gizmos for these so we can watch all of it. Right now, again, that's all defaulting to 0, 0 because that's just the default value. I think we would probably, during start, may want to set its target's position at least to its home location, but we definitely don't want it going to 0 because that could probably cause a few problems there. So let's go in and jump into start. So we've already got this home position variable that we were using. Right after it, let's at least set target location to home position so that it's not going to want to try to go to the center of the screen like during a loading frame or something. That way at least it snaps there. Alright, so with that we can begin making the move method. And the move method is a little intense. And we'll put it right here. Or it should be protected. Alright, so the move method is going to basically see if the monster is going to be bumping into another monster, and if not, then it will begin to move in that direction. So we're going to start with the... Oh, we need to actually set up the target location. So we're going to find the player and set it to be the target. Well, rather, the player's transformed to be the target. And then we set our target location to be that position. This is going to, we're going to move this. That's going to be moved on to the AI stuff when it decides where to go. But for now, we're just going to quickly crunch the target location to be the player. It's going to just automatically find the player in the world and set the target location to it. So now we're going to calculate the vector to the target location. And that's pretty straightforward. We're just going to say target's direction vector is going to just be the target, if I can type, target location minus transform.position, which is this creature's current position. Now it's actually mad because the minus operator is ambiguous between vector 2 and vector 3, so it's just cast the position to a vector 2. Because it is giving it as a vector 3 because it has an x, y, and a z, but we only want to think about this in x and y, so we just cast it to be a vector 2, which you can do. Then we want to normalize this to a unit vector which has a magnitude of 1 so that we can multiply it by the move speed, because regardless of the distance to the player, the player might be 100 units away or the player might be 2 units away. We just want the direction to the player. The amount of distance is going to be handled by the move speed, so we want to normalize this. So target direction vector dot capital N normalize, and that will actually change that vector 2 to be a unit vector. So now we have a direction to the player. So let's now calculate the distance to see if we're going to overshoot. And the issue with that is, like, if it's trying to go to a location and its move speed is too high, it could just miss that location and never actually land on it and never be happy and just kind of constantly be shaking and moving back and forth. And so that's what we're going to do here. So we'll do float distance equals vector2 dot distance between the target location and transform.position, which is the monster's current location. So it calculates how far is it from where it wants to go. And then we're going to create a target move, which is how much the monster is going to move in a single frame, which is the target direction vector times move speed times move modifier times time.delta time. So we're seeing how far it's going to be going. And so if that distance is less than the target move magnitude, then we want to just change target move to purely just be the location minus the position of the monster. All right, so we have done that. So then let's go on to checking to see if there's anything in the way. Well, they'll just shove each other around. Let's skip that for now. Let's see what happens. So let's just do the movement here. So we'll do body.velocity plus equals a new vector 2, which is going to be the target's move dot x times 0.02. But this is the physics-y movement. If we wanted to do the original, like where the monster just kind of moves directly to something, that would just be body.move position, and we could do body.position plus target move. I'm going to overhaul this. And do this with another way, but this is kind of the simpler way to handle movement. It just makes the monster go directly to wherever it's going, rather than using the velocity, which is what we did for the player. So let's hit save. This will work. It should just be a simple movement, but I do want to make it a little bit more complex. It's going to head straight towards the player, and it's going to not use necessarily the physics. So that means over here in orange blob, we're going to call fixed update. And if we are not stunned, notice how it has access to this stunned variable, even though I didn't declare it up here. And that's because it's inheriting all the protected variables from enemy. So any variable labeled as protected is allowed to show up in the child class. So it has access to this is stunned variable. Oh, I think this thing called this on animator move. No, we want that just to be called move. I don't know how I didn't notice that. And so over here, we're just going to call capital N move. We'll hit save. So it's going to call this method if it's not stunned, and it should kind of just directly move towards the player. And it's going to shove the player around. So let's see what that looks like. So you can see that the blobs, they're just moving directly towards the player. And they get kind of shovey when, as you can see, they push the player around. And that's something we're going to need to change, because that's not really a desired gameplay trait to just kind of push the player rapidly around like that. So we want the blob to stop moving when it's about to move into the player, and that's going to be what we need to do with this code. So we're gonna kind of comment this one out because this is the old way. And let's go do the velocity way. So body.velocity equals new vector2 target move.x times 0.2, just to kind of make it slightly smaller. And target move.y times 0.2. So this is going to do a velocity-based move, which is actually going to be better for the long run, because we will be able to let the monster be affected by things such as different friction surfaces or ice or any of that. But by doing this way, we do need to check to cap the speed. So we do need to do the body.velocity.magnitude. If that is greater than its move speed, then body.velocity will be set to its current velocity, body.velocity.normalized, which drops it back down to a size 1 unit vector multiplied by the move speed, which kind of guarantees the magnitude of the move speed is the same as its move speed. Again, I hope you enjoyed taking physics. So that's still not going to fix the problem right now. It's just changed their movement style. Oh, whoops. Right now the issue is, because I'm multiplying time.delta time in right here, it's causing this to actually be too small. Because if you're using velocity, delta time's kind of baked in already because it's only going to travel units equal to the time dot delta time. So if I take this out, then that's a more appropriate thing. And then this is still going to apply because if the distance is closer, it is going to make it move a little bit slower. So it's going to slow down a little bit as it gets closer to its destinations. A little bit slow on the blobs there. Let me check their move speeds. So they have a mass of 10 and a linear drag of 3, which should be about right. Move speed is 3, which also should be about right. I think my concern now is this line. Maybe it's making them too slow from the get-go. Oh, this needs to be plus equals right here. Because it needs to add to the vector, not just set the vector to half of that. Easy to make those tiny little typos. There we go. Now we have blobs moving basically at rocket speed towards us. So could be worth thinking about, should the blobs be slower? They do kind of push each other out of the way, as you see. And they still push me, which again is something that we don't really want to get into a shoving match with the monsters. Now they're going to strike me, so I don't know how big of a problem that is kind of in the long term, but I do feel like this shoving match is kind of silly. So let's prevent that shoving from occurring. So inside of the orange blob, inside of the enemy, we want to check to see if the move that it's about to make is too much. So we want to see if it's clear of the player so it doesn't shove the player. Now we could include the enemy in here too, and so we can make this a little bit more interesting. So let's go with calling Boolean clear is true. We will assume that it is. And we will also assume that they're not blocking the ally. So we need to then also get a copy of its collider. Now, some of this code is specific to it being a circle, so that's actually why I got the circle collider. So I'm going to calculate where it's going to end up. So this is called my future center. And I am multiplying in time.delta time into here because in this scale of thinking, I do need to factor a per frame calculation. Then we calculate the radius of the monster. And again, I'm doing this so that it is not dependent upon anything that I specifically set. It will work for anything. This one's kind of weird. I'm taking the radius of the collider and then multiplying it by the scale factor. To make sure that it is correctly scaled. I'm choosing the larger of the X or Y scale, so just to give us some leeway. So then we detect the colliders that if the enemy takes this move, that it would actually hit if it were to take that move. So we create an array of collider 2Ds, and I'm just going to call it things, and we'll use a physics 2D command called overlap circle all. And that returns a regular array of all the colliders that will be found at my future center, comma, my radius. So where I'm projected to be in one frame, will I be hitting any colliders, such as a player? Then we've got to check to see if any of those are actually players. So for each collider 2D, temporarily called item inside of the list things, if that is my collider, then ignore it. So just continue, and that causes the loop to go back up to the top. If item dots compare tag is either an enemy or item dot compare tag is a player. So if it's an enemy or a player, then clear is going to be false. We shouldn't move. And this should help prevent the enemies from pushing each other around. And if it's going to hit an enemy, then we'll set blocking ally to be true. So now going to here at the actual movement of the monster, we're only going to move if clear is true. So if it was going to be a safe movement. And so we're only going to apply this extra velocity if the direction that I want to go in is clear. Now, I'm going to take a moment to see if it's going to cause any issues with its allies. Notice I have not used this blocking ally yet. Maybe we'll tweak it. We'll see. So you can see that the blobs are not wanting to continue aggressively pushing the player. And I probably don't need to really mess too much with the blocking ally business. But notice how, like, if we get it perfect, they do tend to jam up on each other. Like, those two were almost going to get stuck on each other if the third one hadn't plowed into it. So we could think about possibly either taking enemy off of the clear thing, or if we want to do something about the bumping it to your ally. So if clear was true, then do that. But otherwise, if clear is false and it's blocking its ally, let's instead just very subtly add some velocity, or, well, it's still going to add it in, but we want to add it in the opposite direction. So we're going to take that target move, multiplied in the reverse. Because if the direction I wanted to go had an ally in it, well, let's try to back it up a little bit and see if that kind of can help us from getting stuck on an ally. These numbers might need to be changed, but that should prevent them from kind of jamming up on each other. And so they're actually far less likely, because actually the one that's in back is going to slow down, and it will stop riding the bumper of the slime in front. And so they'll kind of naturally unstack themselves pretty easily. Curious to see if they stop any sooner if I take out the math max part. So they're actually kind of moving backwards a little bit because the blocking ally code is making them want to go back. So like this one, you can see it is no longer going to be doing that because there's no ally that it considers to be blocking. And so that's pretty good. I do think it needs the multiplying in of the scale factor. I don't think that radius is the true radius. I think that's the radius that gets set. So if we actually want a more flush, it's like this is actually going to take the enemy flush up to the player to the point where it's literally like any frame movement will cause a bump. Alright, so that looks good. We can... Actually, that's the drawing the lines to the player. I totally was not paying attention to that. If I turn on the gizmos, we can actually see them tracking the player with the lines, which looks kind of cool. Okay, so that looks good. It looks like they're behaving correctly. And so that's actually the enemy's move method right there. The only thing that I could consider adding to this is a similar thing for the player, so that the player isn't going to be able to shove the monsters around like that. So let's go and take this part about checking to see if it's clear, and let's take that, copy it, jump over to player real fast, and go to the player's movement method. So you might take a little bit to find that. And then right here at the top, before we actually move, let's do the same thing. I don't need the blocking ally piece, so I'm actually just going to take that out. And if I'm bumping into a player, I guess. But my thing is not called target move. Instead, mine was called, I want to say move. And it does not have time.delta time multiplied in, so I do need to multiply time.delta time in there, so it's fine. Collider, all that looks good. All that is fine. And so we just need to add the if statement right here. If clear, then actually let the player move. So this will then prevent the player from forcefully moving into the enemy. Now the player's velocity still could push the enemy, but we're not allowed to add any additional velocity if it would push us into an enemy. So we bump into each other, and I'm facing the blobs. I'm not allowed to push them. They're not allowed to push me. And then the pushing match is thusly over. We could also consider that if the blob hits the player, maybe the blob needs to not move, because you can see that it's like shoving the player. And we still kind of like bounce into the slimes when we hit them. So I don't know, that's something to consider. If that's not really feeling like a style you want, obviously you can just change that. But I would just probably take this out, take out that if statement, and you can keep the rest. But that way it prevents us from pushing the monsters, and it prevents the monsters from pushing me. Now you still bump into them when you first collide into them. That can be sort of addressed a little bit. We can add it down here. So we can add private void on collision enter 2D. So if we've collided with something, so if we are not stunned, and other.compare tag. Oh, I guess I need to get the game objects. If that tag is enemy, then we could set the other.gameObjects.component rigid body 2D dot velocity to the 0 vector. And we can also do the same for the player. So we do body dot velocity so if the player hits an enemy while they're not stunned, so if they're under their own movement, if we bump into each other, it will prevent movement. It should set both of their velocities to 0, so there shouldn't be any of this like slidey bump to each other. So you can see they just like hit me once and that's it. The only thing that is it does get the movement feels sticky if you're trying to move diagonally away from them, because while I'm holding forward, it's ignoring the fact that maybe pushing in one of the directions would have been safe, but oh well. But yeah, so that kind of handles our movement. Now there's no longer any shoving matches. When two things collide each other, we just stop. There's an initial bump, but then everybody stops. And so that's going to wrap up our movement code here. The enemies move. Now our next goal is to get them to intelligently decide to chase the player. So they're going to have an aggro radius, and they're only going to chase the player if the player attacked them or if the player steps inside of there. So that's going to be the video on the enemy AI. So I'm excited to do that, and the enemy will start getting a little bit more realistic at that point. So thank you for watching.